Hello class, we are still in section 9.2 and we want to see how to test the mean value when the standard deviation is known, and we're going to look at a two-tailed test. Turn back with me to page 437 and let's look at our procedure again. The first step says, in the context of the application, which is this question here, state the null and alternate hypotheses and state the level of significance, alpha. Read the question very, very carefully to make sure that you have all the information that you need. I have my null hypothesis of H0 is the mean equal 8,500. And my alternate hypothesis is mean is not equal to the 8,500. So make sure you read the question very carefully. On this one, it's a little different than our other two because I want you to notice that on the other two, they gave me something like less than, greater than. This one, it doesn't say anything like that. So our alternate hypothesis will be the mean is not equal to 8,500. And we know that when we find our null hypothesis, we'll take our mean equal to that value that is given to me. Very important. We also have some more information given to me. They have also told me that the sample mean is 8,120. The standard deviation of our population is 950. We know that n equals 30. And our level of significance is 1% this time. So we have completed step 1. We have identified the null and alternate hypotheses, and we also identify our level of significance, which is 1%. If you go back to page 422, we can identify this as a two-tailed test. The two-tailed, it says a statistical test is two-tailed if H1 states that the parameter is different from or not equal to the value claim of H0. So we know it's going to be a two-tailed. And it's going to look something like this when we look at the two-tailed. Let's go to step 2. Step 2 says use the known standard deviation, the sample size n, the value of x from the sample, and the population mean from the null hypothesis to compute the standardized sample test statistic. And we've already identified some pieces of information, but let's write down some of that information again. Again, we know that our sample mean is 8,120. Our standard deviation for the population is 950. N is 30. And we have our population mean, which is 8,500. So we're using the exact same test that we used in our previous notes. Z equal X bar minus mu over sigma divided by the square root of n. Plug those values in. I have the 8,120 minus mu, which is 8,500, divided by my standard deviation, 950, divided by the square root of 30. When I calculate that information, and again, you can calculate it using the Desmos scientific calculator or use your TI graphing calculator or a scientific calculator, you should get Z equals negative 2.191. So remember, we're doing a Z distribution when we have our standard deviation for our population. If we do not have our standard deviation of our population, then we use a T distribution. So make sure you know that. Okay, very important that you know that. So we want to know, is this our rejection region? Now, it is some other things you can do. You can find your Z critical values, and that's also in the back of your textbooks as well to find that. Or we can go ahead and look at our generator and find out what is our p-value. So you notice I had Googled the p-value generator, and I clicked on the very first link, and I want to click on where it says p-value from z-score because we had found our z-score. We want to input our information. We have a z-score of negative 2.191. We have a significant level of 1%, which in decimal is 0.01. And this time we know that it is two-tailed because our H1 had a mean value not equal to 8,500. So it is two-tailed. And I want to calculate. And when I calculate that, I have a p-value of 0.028452. And that is my p-value. Very easy. So my p-value is 0.0285. So again, we want to think back at what does the p-value tell me. So we want to take our p-value, which is 0.0285, and see if it is greater than 0.01. And I can see that this is a true statement. Again, if you think about a dollar amount, you'll think about 3 cents rounded is greater than 1 cent. So we know that this is a true statement. So because this is true, we are now on step 5. We have already completed steps 3 and 4. We are now on step 5. It says interpret your conclusion in the context of the application. So we are actually on step 4. We want to know, do we reject or do not reject our null hypothesis? So because my p-value is greater than our level of significance, it tells us that we do not reject H0 at 1% level of significance as P is greater than 0.01. And we know P is at 0.0285. Now we're on step 5. It says interpret your conclusion in the context of the application. What does it tell us? It tells us there's not enough evidence at the 1% level of significance to suggest that the daily average of cars using the road is different from 8,500. Very easy. That is it on how to test the mean when the standard deviation is known and looking at a two-tailed test.